All right, so let's see how we did. So in this triangle, notice how we're starting with the smaller half side. So if this is 7 and that is half of what the original length is, then that means the hypotenuse has to be 14. Okay, let's also fill in the angle measures as we go along too. So this is my 60-degree angle, and up here is my 30-degree angle. So now again, just like we've been doing, we need to figure out what is the median of this special right triangle. So I'm going to use my Pythagorean theorem. 7 squared plus m squared equals 14 squared. And 7 squared is 49. And then 14 squared is 196. And then minus the 49 from the 196. So m squared is equal to 147. Now, to undo a square, we square root both sides. So we need to break down 147. So let's see if 3 goes into it. And it does. So 3 times 49 gets me 147. And 49 breaks down to 7 times 7. So what comes out of the radical? The 7's come out and the 3 stays in. So the length of my missing side is 7 times the square root of 3. Okay, so let's look at the next one. So if my length of my hypotenuse is 2, then this side is half of that, so that's going to be a length of 1. Using my Pythagorean theorem, 1 squared plus m squared equals 2 squared. Four minus 1 is 3, so m squared is equal to 3. How do we undo a square? We square root it. 3 is already broke down, so m has a length of the square root of 3. Are we starting to notice anything? Starting to see a pattern. What has occurred every single time? So let's do it one more time. And if you've not already figured it out, I could probably go ahead and do this one without even having to go through the Pythagorean theorem, but we'll check it to see. So again, my hypotenuse is 12. That means this length is 6. So just by basis of appearance, every time in all of the triangles that we looked at, it appeared that the length of the median was always the length of the half side, the shorter side, times the square root of 3. 4 times the square root of 3. The next one was 3 times the square root of 3. Notice how this one was 5 times the square root of 3. And see, this 5 was easy to come up with because it's always half of the length of the hypotenuse. Again, that 3 was easy to come up with because it was half of the length of the hypotenuse. In this one, it was 7 times the square root of 3. This one was just the square root of 3, but if I times a 1 by that, it's not going to affect it. So what do you know? 1 times the square root of 3. So just using deductive reasoning and noticing the patterns, I guarantee you that this one's going to be 6 times the square root of 3. So now let's see if we're right. So 6 squared plus m squared is equal to 12 squared. 6 squared is 36. 12 squared is 144. 144 minus 36 is 108. And then square root both sides. So 108 breaks down to 3 times 36. And 36 is 6 times 6. And there you go. Your 6's come out. Square root of 3 stays there. So what do you know? So in E, it says, write a general formula for this triangle. So like we did with the 45, 45, 90, we're going to write a general formula for the 30, 60, 90. So here's my right angle. This angle length is 60 degrees. And this angle length up here is 30 degrees. So if my segment here, let's call it X. So if that leg is X units long, the hypotenuse every time has always been double that. Double 7, you got the 14. Double the 1, you got the 2. Double the 6, you got the 12. So that means this one has to be 2x. And then my other leg was always whatever this length was times the square root of 3. So the length that goes with the 30 degree is going to be x. The length that goes with the 60 degree is going to be x times the square root of 3. And the length that goes with the right angle, the hypotenuse, is 2x. So we can use this formula or this ratio to figure out the side lengths of the special right 30, 60, 90 triangles without even having to use the Pythagorean theorem. So in the next lesson, you are going to be applying what you've learned and looking at several examples and then practice.